Welcome back. I'm Professor Gallaugher. This is the solution video for question 5 in our 9-question, 2.5-hour midterm exam. Feel free to start at the first video if you want to see how I set up this test and my approach for grading in a way that encourages rather than discourages students to conquer tech challenges. And the previous videos also include the first few questions and answers. So question 5 is based on a Buddy the Elf Christmas build that I did a while back. So Buddy the Elf is the title character in the movie Elf. He's played by Will Ferrell. Here's a look at the build.
Hey! What's your name? My name's Buddy.
Now there are a bunch of metallic bows attached to the CPB's capacitive touch pads. Touch a bow and a particular Buddy phrase plays, and while that phrase plays, a servo motor moves a fishing line attached to Buddy's hand, so he waves at you. So in this build, for answering the question, I've asked students to download 2 of the sounds from the URL that I gave them, then attach 2 alligator clips to capacitive touchpad A4 and A5, and they're not going to do the full build, but they should create a function called sweep_arm, and this function should move from 50 degrees to 135 degrees in 3-degree increments with a 2/100ths of a second pause between degree movements, and then once we hit 135 degrees, we should sweep back to 50 degrees again at the same pace, and sweep arm should continue to run as long as one of the sounds is playing. Those sounds start playing when you touch one of the capacitive touch pads. That's the build. Let's take a look at an answer. So much of this build should be familiar. The things that you need to import are board time, digital I/O, touch I/O, and PWM I/O, and we need to import a bunch of different things to work with audio, audio out, wave file, and servo from the audio PWM I/O, audio core, and Adafruit motor libraries. Actually, what we're doing is we're importing PWM audio out from audio PWM I/O, and we're renaming that as audio out. Now down here we also set up our speaker. Again, we've done this several times, so this is the way that you set it up on a Circuit Playground Bluefruit. We set a path which we use when we actually play our sound, so this is where our sounds can be found. The path needs to be named exactly as the folder is that's on your CPB that contains your sounds, and you have to make sure that you have the slash at the end of it because that separates the folder name from the name of the file that you're going to be playing. We set up our touchpad A4 and A5. Some students set this up in an array. That's totally fine, but we didn't really need to have an array since we're only using 2 touchpads. Then down here is where we set up the PWM necessary to set up the servo. We call this servo _1, and you can fine tune your servo if you need to change the min pulse or the max pulse to make sure that it sweeps at a 180-degree arc. I didn't worry too much about that. I assumed that the servos were roughly calibrated for this. We didn't need a super amount of precision to wave Buddy's arm. Then to run the program, what we do in the while true loop is if touchpad A4 is played, we play sound Buddy wave, and if touchpad A5 is pressed, again we do that by checking the value property to see if it's true, we do a play sound with smiling wave. Now play sound is a function that we've seen many times in our previous class and in our lessons, so we just open up the particular file name at the path. It's binary initially, and then that's going to be named wave file. Then we take this wave file, which is, since we read in binary, it's 1s and 0s, and we convert this into a wave file that can be played. Then we call audio.play. Audio is the object that we'd set up here so that we can go ahead and perform audio out. And we're able to play wave, and then while the audio is playing, we usually put a pass in here if we have nothing else to do, but we replace pass if there's something that we want to do while audio is running. And specifically what we want to happen is we want to run the sweep arm function as long as the sound is playing. So what do we do in sweep arm? Well, that function is defined up here. We're going to go in the angle from 50 to 136. Remember, 135 plus 1, because we never get up to what our ending value is here, 136. We'll stop at 135. 3 is the increment that we're moving up at. Remember, we're going to move up in 3-degree increments, and we just move the servo 1. We set its angle property to whatever the angle is that we're looping through, and then we wait for 0.2 of a second. We move down in the opposite direction, so we start at 135, we go to 49. This will stop us at 50, and we go in -3 increments instead of 3 increments, but the setup is exactly the same as it is above. So that's it. Hopefully you got this. I think most people did. Congratulations if you did, and if you didn't, well, now you know how to do it.